Let's play a game. One of these dashing knights is a human, a rather novice friend of mine. The only human, actually. The other three are all an AI. So which of these is the human? I'll give you a moment to try and figure it out. The correct answer was 4. My friend isn't very good at the game. This is For Honor. It's a 3D fighting game released by Ubisoft in 2016. It's also one of my favourite games of all time. And so, for my university computer science project, I thought I'd make a neural network that learned to play it, despite the fact that I had absolutely no idea how I was going to do that. What you see here is the currently finished result. He plays Warden, one of the most simple heroes in the game, on the ring map with stamina disabled. Now, unless you've been living under a rock, or been a complete shut-in like I have been for the last 4 months, you've almost certainly at least heard of neural networks, but perhaps you don't know what one actually is. If you do, you can skip to here where I talk more about how this neural network works. If you don't care at all about how any of this works, and just want to see him fight, then skip to way over here. It's not going to be a very technical video in any case. An artificial neural network is a structure of these circle things, often connected in this layer pattern by lines. Each circle is called a node, or a neuron. The lines are like your axons and dendrites. Now, I don't actually think they work much at all like our actual brains. Essentially, in the most basic kind of neural network, you feed these neurons some information, they process it in a way, and then feed it on to some, or sometimes all, of the neurons in the next layer. Each line has what's called a weight associated with it, that affects the information being passed along that line. This keeps going and going till you get to the last layer, called the activation layer. In the activation layer, the neurons should represent the actual problem you're trying to solve. So, for example, if you're trying to solve a classic problem where you're trying to determine whether a picture is of a catto or a doggo, you could have just a single neuron at the end to represent either a cat or not a cat, i.e. a dog. During training, we test the network on some training data. If it gets a test wrong, then we adjust the weights I mentioned earlier, just a little bit. That way it becomes a little bit better at guessing correctly. We do this entire process over and over in what's called backpropagation, and that is how a neural network learns. But let's go back to that activation layer for a moment. What does an activation neuron actually output? Well, the two main different outputs are to either be a 0 or a 1, or a number between 0 and 1. For a catto or doggo classifier, you'd output a 0 for Fido and a 1 for Ezio. Yes, that's really my cat. So, what did I do for this neural network? Well, there are 13 main buttons. Move forward, left, back, right, guard top, guard left, light attack, heavy attack, guard break, dodge, feinting, and taunting. Plus an extra one to represent pressing nothing at all. Hooray! I made each neuron output a number from 0 to 1, and treat it as a probability, so if the number is over a certain value, then Neural Knight presses that button. It essentially acts as a representation of how confident Neural Knight is in pressing that button. But what is the information that you feed in to this whole thing? That depends on the problem. For our catto and doggo machine, you could just feed it in the picture. With Neural Knight, it's a little bit more complicated. In the end, I gave him 3 different inputs. One was a list of the buttons I pressed in previous frames. Another was a screenshot of the current frame that's been shrinking down so that there's less information to process. The third is information about the duel at that very frame, like guard direction, whether there's currently an attack, a guard break, a bash, etc, etc. Now, if you're watching this video, you've probably also seen the videos and such of other self-playing AIs, like OpenAI's 5, that plays Dota 2, and DeepMind's StarCraft 2 stuff, or the wonderful Sethbling's MariFlow, and Sethbling's amazing MariQ reinforcement learning thing, which he released whilst I was making this. Awesome. Mine differs from these sorts of AI in a couple of ways. There are, for all intents and purposes, two main types of learning behaviors: supervised learning and unsupervised learning. Unsupervised learning is where we learn on the go, because we don't know what the right answer actually is. We don't know what we're trying to achieve precisely. Unsupervised models generate what they think might be a good answer, and then the answer is given a score. Using this score, they rank each other, and they improve over long iterations by breeding the best of them and killing off the worst, while adding in random mutations along the way. That's generalizing quite a lot, but this video isn't supposed to be super technical. The projects I listed before are all unsupervised, aside from MariFlow. Supervised learning is what Neural Night is. We train the AI in a separate process outside of the game, because we know what the correct answer is during the training process. This required me to record a bunch of training data beforehand, which was a couple of hours of fighting a level 2 warden, and using my data capturing system to record it all to a file to use for training. For each frame, it would link it with what buttons I was pressing at that given moment, so it was incentivized to press the button I would press in that situation. So Neural Night is, in effect, learning not to play well, but to play like me. Most other projects you'll see of this nature also share another big similarity, and they're also why they probably perform quite a lot more effectively than poor old Neural Night might. I mentioned that one of the main inputs the neural network gets is information about the fight situation. Well, that has to come from somewhere. For example, OpenAI teamed up with Valve and got a direct hook into Dota. Same with DeepMind and Blizz for StarCraft. Lots of programmers make AI for old arcade games because they can run them in emulators and access the memory directly or with plugins. Me? Well, I don't work for Ubisoft. At least, not at the time of recording. Wink wink, nudge nudge. So I didn't have the luxury of just getting the guard direction and such. So therein lay the first half of the project itself. How was I to retrieve the input data? The answer was computer vision. Computer vision encompasses the entire field of algorithms and tools that allow computers to understand what they're seeing in images and video. And that is exactly what I needed to do. I needed to capture the game's frames and pick them apart so that the AI could know what's going on. I won't go into loads of details about how I did every single part of this, but suffice it to say that it took me quite a long time. I didn't know a single thing about computer vision and had a lot of learning to do. Neural Night has two separate eyes, as it were. One eye for the guard direction, and another for, well, everything else. Just as an example of the kinds of methods I employed, to detect the guard direction, I cropped and filtered the image a whole bunch, and then applied a line detection algorithm to convert the guard UI into a series of lines. I then analysed the gradient, also known as the slope, of each line, and used that to determine the direction of the guard, since each of these 6 lines have a unique gradient. Methods like these allow me to make scripts like an autoblocker, and then even this little test to parry 400 millisecond lines. It wasn't perfect, but it had to do. I only had 4 months to make this entire thing after all. It was, unfortunately, due to this time constraint that I couldn't capture the health or stamina. I've got another plan to use unsupervised learning with these pieces of information, but that's in the future. So, using a whole bunch of computer vision techniques, I capture the important game information going on at that very moment. If you'd like to know more, stick around till the end. So, those are the inputs. I won't explain how the actual nodes work too much. It's a lot of operations on matrices of numbers. In the end result network, each of these branches happen to use a different kind of node. The computer vision branch goes through what's called a one-dimensional convolutional layer, which tries to break down what it sees into little components, and break those down too, so it can try to figure out how these individual components fit together sensibly. The image goes through a two-dimensional convolutional layer, which you'll often see used for image recognition in general. It's trying to do the same thing, break up the frame into components, and break those up too, so that it can find and recognize patterns. The input history uses a long short-term memory layer, or LSTM for short. LSTM units are quite different. In a nutshell, every time they receive some input, they choose some stuff to remember, some existing stuff to forget, and then process it before outputting it to the next layer. Ending up with this final network structure and tuning it took a lot of time. It was the majority of the remaining time I had on development, and the result of a lot of failure. But I got there in the end. So, to summarise, I captured a lot of training data, which essentially served as a set of questions and answers. I trained the network off of this data, where each time it would try to predict what buttons I pressed. If it got them wrong, it made small adjustments to the weights. It went through the entire training set about 100 times, and voila, Neural Knight was born. Neural Knight's performance can fluctuate, but when he's in his element, he can pull off some genuinely impressive moves. He only knows how to fight other Wardens, but he can counter their vortex, parry lights and zones, and even crushing Counter-Strike. I'm genuinely really proud of him. Let me show you a little bit of his decision-making process, by showing you what Neural Knight sees, and observing his behaviour from moment to moment. I'll pick apart one of his more successful fights, so you can have a bit of a better idea as to how he thinks. His memory only lasts a few seconds, so he's very much not yet able to play the mind games we normally play, but he can make up for that with some, at times, inhumanly good reactions. Okay, so he starts off with a feint. That's actually pretty random, which is my fault, as I don't give him very many examples of myself feinting, to keep it simple. He sees the attack from the window with the red on it, and knows from the data that he should match his guard there, and thankfully, he follows through with that. He follows up with a light attack, and knows that lots of times I've ended up following a light attack with a shoulder bash. Now, that's usually because I'm doing the confirmed double side light that you get off of a shoulder bash, but he doesn't really have that context. So here, the enemy goes in for a heavy, and sometimes the stars align and the environment matches enough that he recognised that I light attack against a top heavy. Now, even I suck at timing this sometimes, as the window is just a few hundred milliseconds and the risk is high. But in this case, he goes for the counter and lands it perfectly. Very nice. And now he's turtling. When he's at his most successful, Neural Knight usually either turtles a lot or goes hyper-aggressive. It's a bit random as to which one he chooses in the end. He crushing Counter-Strikes again. Funny thing here is that for once the tables were turned, and he taught me something. I didn't actually realise that you got the weird second light off of a crushing Counter-Strike. I think he started doing that accidentally when he learned about the double side lights from me, and just disregarded the guard direction. When that made me realise that the double caching Counter-Strike was a thing, I started including it in the training data. So that's pretty neat. So here he follows through perfectly with probably one of the easiest things that I've taught him. I tried to be quite consistent in my button presses during the training recording, and I always rolled away from the shoulder bash, as that's a pretty safe bet, especially against bots. Here, he's being a little dim, not really realising he's too far to do much, but the bots close the distance anyway, so it doesn't really matter. When he sees the attack coming in here, you can see in the command line that he actually tries to both parry and crushing Counter-Strike here, amusingly enough. If I actually switched up the priority of the button presses to make light before heavy, I think he would have done the latter. But instead he parries, which is fun for this example because I always trained him to zone off a heavy parry. And then again. GG. God, that was so cool. Let's see that again without all my interruption. I'm so proud of you. He's only trained off of a few hours of data, like I said, so I bet he would be even better if I trained him off of even more, especially if it was a pro warden instead of me. I confess I actually main Orochi and Centurion, but I'm a knight at heart and I'd be damned if I wasn't going to train a robot knight to fight, especially the most fashionable of knights. Except for maybe Blackfriar, I guess, but he wasn't added to the game until after I'd started working on it, so... I also think he'd perform better if I could increase the size of each layer in the network, the number of neurons per layer. As it was, I had to train it off my own machine with my limited RAM. If there's demand for the source code, I can make a public repo for it. In the meantime, if you really want to know how it all works, then, well, read the paper. I did this for my bachelor's project, and so you can read every single step that I went through. It's linked in the description. If you can't be bothered to read the paper, and I don't blame you, but are interested in seeing my progress, I've slowly built a playlist of videos that showcased any interesting results I came across at the time, and it's now been made public. You can check that out in the description as well. I also have this cool poster. It's pretty neat, I think. It's not for sale or anything, but... Also, I'm now done with university. So, Yubi, if you're watching this, you know, I'm available. That's about everything. Thank you for watching. I was originally going to commission a bunch of art of Neuronite as a cyberpunk hero. I guess I'll just have to fulfill that role myself. Thank you very much to my university for even allowing this to be a project, and thank you to my friends for beating Neuronite in fights over and over and over for many hours. A special thank you to Scentdex and his entire Discord community, especially Daniel. Without their technical support, I would have never been able to make this. Cheerio!